everyone, welcome to my physics YouTube channel. Let us see today a very simple example about unit vector. Number one question. Plot the following unit vectors and determine whether they are standard or non-standard unit vector. So let us see these unit vectors and plot them in the graph, and then we will determine whether it is standard unit vector or not. For number one, the components for the unit vector A is 1 along the x, 0 along the y, 0 along the z. So if you find its magnitude, you will get 1. Therefore, this unit 1 is, you can plot along the positive axis, So since it is lie along the positive axis, so this is standard unit vector. For B, 0 along the x, y along the y, 0 along the z. So its magnitude is the same. The magnitude of the unit vector for the B is 1. So its 1 lies along the positive y-axis. So this is standard unit vector. For C, it's the same. 0 along the x, y along the, 0 along the y, 1 along the positive z-axis. So you can plot for C, for the C, sorry, this is not. For the unit vector C, it lies along the positive z-axis. It lies, therefore this is standard unit vector, because we define that standard unit vectors are unit vectors that lies along the positive axes, coordinate axes. So for question number 4, D, the unit vector, for the unit vector, the components are 1 divided by the root square of 2 along the x, 1 over the root square of 2 along the y, 0 along the z. So if you draw this, if you plot along the three dimension Cartesian coordinates, this one you can rewrite like in the decimal form: 0.71 along the x, 0.71 also along the y. Then this is 0.71 along the x axis. Then it lies also 0.71 along the y. This means the same. 0.71 along the positive y. Then if you connect these 2 points, the unit vector lies here. This is the unit vector. Its magnitude is its magnitude is 1. So always, okay, if the magnitude of the unit vector lies between the positive coordinate axes, this one is, we call it what? We call it non-standard unit vector. So non-standard unit vectors, okay, it may lie along the positive z-axis and x. It may lie here, or it may lie here. Therefore, if it lies along in between the positive coordinate axes, we call it is non-standard unit vectors, okay? And then for E, for the case of E, it is -1, which means the negative vector of the standard vectors, -1, okay? Therefore, let's see here, E, this is the positive axis, so the negative axis is this one. This one is the negative axis. Therefore, if the vector lies along the negative axis, we call it what? We call it standard unit vectors, okay? So for all the same, for F and G, they are lie along the negative axes. So for G, it is lies along the negative y-axis. The magnitude is lie along the negative y. So this is non-standard unit vector. For G, the same. It lies along the negative z-axis. The negative z-axis is this one. This one. So this one is also non-standard unit vector. So generally, okay, non-standard unit vectors, they may lie along the negative axis, or in between the positive axes. If they lie in between the positive axes, we call them non-standard units. If they lie along the negative axes, either it is negative x or negative z or negative y. We also call non-standard unit vectors. So generally we can define standard unit vectors lies along only along the positive axis, along the positive either positive axis x or y or z. So for today it's enough.